नमस्कार दोस्तों, मैं आपको बहुत बहुत स्वागत करता हूँ अपने YouTube चैनल। इसका नाम है दयाल एंड सन्स क्लास ऑफ केमिकल साइंसेज में, और लेके आया हूँ आपके बीच क्वांटम केमिस्ट्री की दूसरी वीडियो। इस वीडियो में हम डिस्कस करने वाले हैं सॉल्यूशन ऑफ श्रोडिंगर वेव इक्वेशन। पहली वीडियो में हमने देखा था डेरिवेशन फॉर श्रोडिंगर वेव इक्वेशन, एंड इन दिस पर्टिकुलर वीडियो वी आर गोइंग टू स्टार्ट विद द सॉल्यूशन of Schrodinger wave equation for a particle in 1D box, and then we will generalize it for particle in 2D and 3D boxes. So let's begin with our video now. Now, in order to find the solution of Schrodinger wave equation for a particle in 1D box, we need to consider a particle of mass m confined in a one-dimensional box of width L, having infinitely high walls, and that V is equal to 0, and that potential energy V is equal to 0 for x less than L, for x greater than 0 and less than L, and V is equal to infinity for x less than equal to 0 and x greater than equal to L. So this consideration has to be made. Now, what does this mean? If the walls are from x equal to 0, this is a schematic representation of 1D box. In this, we have a box of length L starting from x equal to 0 to x equal to L. Now, if the x is less than or equal to x is less than 0, then V is equal to infinity, and if x is equal to greater than 0, then also V is equal to infinity, and for any value of x between 0 to L, that is from between x equal to 0 and x equal to L, the potential energy is assumed to be 0. Now, for 1D box, we know Schrodinger wave equation, for one dimension is given as del square psi by del x square plus 8 pi square m upon h square into E minus V is equal to 0. Right? We know that for Schrodinger wave equation for a 1D box is given as the del square psi by del x square plus 8 pi square m upon h square into E minus V is equal to 0. You mark this as equation 1. I hope this much is clear. Now, let us first find out what happens to this function, this equation. Now, since inside the box, let's consider a case inside the box first. Now, inside the box, what is happening? V is equal to 0. Therefore, equation 1 will take the form del square psi by del x square plus 8 pi square m E upon h square. Sorry, I missed here. Psi is equal to 0. This equation will reduce to this form. This particular equation will get reduced to this form inside the box. Inside the box, we have V is equal to 0. I put V equal to 0. When we put equal to 0, E minus 0 will give me E. So the equation becomes del squared psi by del x square plus 8 pi square m E upon h squared psi is equal to 0. Now, this equation, if you see, or we can write this equation as del square psi by del x square plus alpha square psi is equal to 0, where alpha square is equal to 8 pi square m e upon h square, where alpha square is equal to 8 pi square m e upon h square. This is equation number 2, and mark this relation as 3. Mark this relation as 3 and this equation as 2. Now what happens? Now if you see this equation represents the differential equation of second order. What does this equation represent? This equation represents second order differential equation, and a second order differential equation in psi has a general formula, has a general solution of psi is equal to a sine alpha x plus b cos alpha x. We have a general for this equation which represents the second order differential equation. This is a second order differential. This is a second order differential equation and it has a general solution. This is the general solution. General solution is given as psi is equal to a sine alpha x plus b cos alpha x. We mark this equation number as equation 4. So what is fourth equation we have get? We have get a general solution for psi, where psi is equal to a sine alpha x plus b cos alpha x. Now the next point now the next thing is to find out the value of this a and b. Our next priority will be solving for a and variable a and b and alpha. For a, b and alpha, we need to find out the values for a, alpha to we know. We will need to find out the value of a as well as alpha also, alpha and b. So if we get the solution, if we want to get a solution for our differential equation, actual solution, what we need to do is we need to find out the value of a, alpha and b. Now how to find this? Let's see in the proceeding part. Now since we have assumed that outside the box v is equal to infinity, outside the box v is equal to infinity, we have assumed that outside the box v is equal to infinity. Therefore the equation 1, which is the Schrodinger wave equation for particle in one dimension, will take the form del squared psi by del x square plus 8 pi square m upon h square into e minus infinity psi is equal to 0. What we get? Del squared psi by del x square plus 8 pi square m upon h square e minus infinity is equal to psi. Anything subtract anything which is subtracted from infinity will give me minus infinity. So what we get? Minus infinity psi. I can write it as minus infinity pi. See, anything subtracted from infinity will give me minus infinity, and anything multiplied to infinity will again give me infinities, but since the sign is negative, we get negative infinity psi is equal to implied del psi square upon del x square is equal to 0, What does this mean? This implies psi is equal to 1 upon infinity del square psi by del x square, implies psi is equal to 0. This means outside the box the value of psi will be 0, right? So what we have got, that outside the box value for psi will be 0. Now what does this implies? This implies that at the walls, that is at x equal to 0 and x equal to L, the value of psi will be equal to 0. This implies that at x equal to 0 and x equal to L, psi is equal to 0. From here we can infer that at x equal to L and x equal to 0, psi will be 0, right? Now we apply these conditions. These are called boundary conditions. We call this a boundary. This is called a boundary condition. So we have got the boundary conditions which bounds this particle in this box. So now we will apply one by one this boundary condition to equation number 4 and we'll find out the value of a, b and alpha. Now let's see how. I hope this much you have written. I just rubbed this part. Just pause the video and note this down first. Okay, I rub this part now. All right. Now boundary condition applying. First boundary condition, that is at x equal to 0, psi is equal to 0. Now we substitute value of x as 0 in this equation and psi and value of psi. Now psi is 0 is equal to, in equation 4, we get 0 is equal to a into, now x is 0, so anything we multiply to 0, alpha into 0 will be 0, anything multiplied to 0 will be 0, that means I can write here sine 0 plus b. Similarly I can write here cos 0, right? Now we know sine 0 is 0 and cos 0 is 1. This implies what I get, a 0 is equal to b into 1. This implies b is equal to 0. So what do we get? B is equal to 0. Now we substitute this value of b in equation number 4. Our new wave function will become, so our simplified way, therefore on substituting value of b in 4, we get psi is equal to a sine alpha x, mark it 5, right? So what happened, we get b equal to 0 and now our wave function is reduced to psi is equal to a sine alpha x. Now we apply second boundary condition. What was that? At x equal to L, psi is equal to 0. In equation number 5. what do we get? We get 0 is equal to A into sine alpha L, right? What will get? A sine alpha L. Now, in order to get this value to be equal to 0, in see, these two are in the product and the result of the product is 0. So for to get the product of these two to be 0, which one of these two will be 0? See, A cannot be 0, because if A is 0, then our wave function will become 0. That means sine alpha x must be L must be 0, and anything multiplied to 0 will give me 0. So from here what I can get? This implies, from here we can write sine alpha L is equal to 0. Implies sine alpha L is equal to 0. Why? Since A is not equal to 0. Since A is not equal to 0. Why we are saying sine alpha is equal to 0? Because A is not 0. Now what happens? Now what do we get? Now for sine alpha L, implies sine alpha is equal to sine n pi. I can write it as sine n pi. Why? Sine n pi means 180 degree, and sine of 180 degree will be 0, and anything multiplied to 180 degree will give me 180 degree in the end, that will be 0. So we can write as 0 is equal to, why? Since sine n pi is equal to 0. Since we know that sine n pi is equal to 0, therefore this implies यहाँ sin alpha हमारा 0 आ रहा था, and we also know that sin n pi is equal to 0, so I can replace this 0 by sin n pi. So I have replaced this 0 by sin n pi. Now what do we get here? From here we get that alpha is equal to n pi. This implies alpha is equal to n pi upon L. So what do we get? The value of alpha to be n pi L. Alpha is equal to n pi L. We mark this equation number 6. We mark this as equation number 6. Right? Now we substitute this value of alpha in our wave function given by equation number 5. What do we get? Substituting value of alpha in equation 5. We get, what do we get? We will get psi is equal to sine A sine n pi upon L into x. Question number, marks by question number 7. So what till now what we have got? We have got that value of wave function is A sine n pi L upon x, but still A is unknown here. We don't know n. Now how to find this value of A now? On applying first condition, we got the value of B, and it came out to be 0, and the wave function was reduced to this psi is equal to A sine alpha x. Then when we apply the next condition, that is at x equal to L, psi is equal to 0, we get that alpha is equal to n pi upon L, and now our wave function is psi is equal to A sine n pi L upon x, but still the value of A is unknown. Now in order to find the value of unknown, what we'll do? Now we will apply. Now what we will do? We will try to find out the probability of finding the electron in this in the given one dimensional box. Now since we have already said that we have a particle present in this 1D box, therefore probability of finding the electron in this particular box will be maximum, and the maximum possibility of finding a maximum probability of finding anything is equal to 1. So what we'll do, we will equate the probability of finding the electron with wave function psi equal to 1. Let us see how. This part. So far what we have got alpha square is equal to 8 pi square m upon h square e. This was the equation number 3. Then we get alpha is equal to, we also get alpha is equal to n pi upon L, equation number 6, and we got psi is equal to a sine n pi L x, question number 7. So far these three information we have got from this particular box. Now probability of finding a particle in 1D box is given in 1D box of length L. Is given as is equal to integral L to 0 psi square dx is equal to integration from 0 to L psi square dx. Now since probability of finding the particle inside the box is maximum, therefore this implies integral L to 0 psi square dx is equal to 1. This means integral 0 to L psi square dx will be equal to 1. Now we replace now the value of psi from equation number 7 to this equation. What do we get? What will we get? We will get integral L to 0 a sine n pi L x का whole square dx is equal to 1. What will get? A sine n pi L upon x का whole square. Or we can write it as integral a square L to 0 sine square n pi L x dx 1. Or I can write it as this: a square integral 0 to L of sine square n pi L x dx is equal to 1. Now what we have to do? We have to find the integral of this, and once we find the integral of this, then we can get the value of a. Now let us see how to solve this integration. There is no integration for sine square square trigonometric function. So what we have to do is we have to convert this square term into single power. And how to do this? For doing this, we will use a trigonometric identity. There is a trigonometric identity which says that sine squared theta is equal to 1 minus cos square, is equal to 1 minus cos 2 theta by 2. Will you make use of this identity, that sine square theta is equal to 1 minus cos 2 theta by whole divided by 2. What we'll do, we will replace this sine square and pi L of x by, now here we have pi value, theta value is n pi L x. We get it 2 n pi L into x by 2. What we'll do, we will replace this sine square n pi L by x. What we'll do, we're going to replace sine square n pi divided by L into x by the relation is equal to 1 minus cos 2 n pi x upon L by 2 in this equation. What will we get? I just step this identity now. I hope you can remember this part. This part you have to remember. What we'll get? We get a square integral 0 to L 1 minus cos 2 n pi L x whole divided by 2 dx. Alright, I hope this much is clear. Is equal to 1 implies a square, I can write it integral L to 0 1 by 2 dx minus a square integral cos 2 n pi upon L x whole by 2 dx is equal to 1. I hope this is clear. From 0 to L, which implies a square. Now integration of half a will be is equal to x by 2 L to 0. Limits are L to 0. L to 0 are the limits, minus a square. This will give me sine multiplied by L upon 2 n pi into cos will become sine 2 n pi L x is equal to 1 0 to L. Now I hope till now it's clear. Now what will happen, we will now write this limit as, this implies a square is equal to L by 2 minus 0. If we replace x by 0, what will get? 0. What is done is upper limit minus lower limit. When we put these limits of integration, we will put as upper limit minus lower limit. Upper limit is L, we replace the value of x by L, we get L by 2. When we replace by the lower limit is 0, 0 upon 2 will give me 0, so I have written minus 0, minus a square L by 2 n pi. Now again same thing, upper limit minus lower limit. Now since there is minus sign is already here, so what will happen, we can write it as, I keep this outside, but I can write sine 2 n pi upon L into L, right, and plus will come 4. We have 1 2 here also, so it will be 4. And sine 0 is equal to 1. This all is equal to 1. Now, why I have written here 0? Lower limit is 0. When I put 0 here, x, and we multiply this with 0, we will get 0. So I have written directly here sine 0. Now we know sine 0 is 0. LL is cancelled here. What I will left with sine 2 and pi. Sine 2 and pi is also 0. This term is 0. This is also 0. So what we are left with, a square L upon 2 is equal to 1. This implies a square is equal to 2 upon L. This implies a is equal to under root of 2 by L. So the value of a is under root 2 by L. So now what we'll do, we'll replace this value of a in equation number 7. What we'll get? We will get the wave function for a particle in 1D box. Now if we replace this value of a in equation number 7, what we'll get? We'll get the wave function for a particle in 1D box, that is equal to under root 2 upon L sine n pi small l into x. So this is the wave function for the particle in 1D box. So this is the wave function for a particle in 1D box. So what wave function we have got? That psi is equal to under root 2 by L sine n pi L x. I hope this much is clear. Now let us find out the energy of particle, total energy of particle. Now let us find the total energy of the particle. Total energy of the particle in 1D box. From where I can get? Now look, the question number 3. Question number 3 says alpha square is equal to 8 pi square m upon h square into E. And the 6th equation says alpha is equal to n pi upon L. So what we'll do, we'll replace the value of alpha from equation number 6 in equation number 3. Substituting value of alpha from equation 6 in 3, we get, what will get? N square pi square upon L square is equal to 8 pi square m p upon h square. This implies from here what will get? E equal to n square pi square h square upon 8 pi square m L. What will get? N square pi square h square upon 8 pi square ml. Pi square get cancelled. So what we are left with? E is equal to n square h square upon 8 pi square 8 ml. This is the expression for energy, where n is equal to 1, 2, 3 and so on. If we need to find out the 0-point energy for a particle in 1D box, what we'll do? We'll replace n by 1. 0 point energy will be the energy corresponding to n equal to 1, and energy corresponding to n equal to 2 will be the energy of the first energy level, and with 3 second energy level, 4 then subsequently higher energy levels. I hope this much is clear. Now what we'll do, we will generalize these two equations, that is the total energy, expression for total energy, and that of wave function for particle in 1D box to the wave function for particle in 2D box. Let us see how. I hope this much is clear. Okay, now let's see for the 2D box how this equation changes for the 2D box. Now in case of 2D box, if you consider a 2D square box of such that its length and breadth is equal to L. If its length and breadth is equal to L, length is equal to breadth is equal to L. We consider a square box such that length and that is of length having side L, that is length and breadth are equal to L. Now for such a box, the psi will be equal to psi x comma y. We write for such system psi x comma y will be equal to psi x into psi y. Psi xy will be equal to psi x into psi y, that is equal to, now from the one dimensional box we know psi x is equal to, we obtained that psi x is equal to under root 2 by L sine n by L x, right? For first one dimensional box we have got that psi x is equal to under root, from that equation we know that the psi x will be equal to under root 2 by L into sine n pi x by L. So we replace the psi x from this equation, and similarly sine y will be, when put x is equal to y, we will get sine y. So what we will get, root 2 by L into sine n pi x upon L into root 2 by L sine n pi L by y. Why I have written L on both sides? Because we have considered that length and breadth of the both the sides is equal to L. That is, along x axis the length is L, and along the y axis also the total length is equal to L. That's why we have got this. So what we can write this as, root 2 into root 2 will be give me 2 by L into sine n pi x upon L into sine n pi upon L y. I hope this is clear. So this will be the expression for the value psi for a particle in a 2D square box of length L whose sides are equal to L. I hope this is clear. Now let us see the energy for this. The total energy in this case will be equal to Ex plus Ey. That is the energy along x-axis, that is energy of particle along x-axis, and along plus the energy of particle dissipating along y-axis. So along x-axis we have already seen that it is equal to nx square h square upon 8 ml square plus ny square h square upon 8 ml square. For Ex it will be equal to nx whole square upon nx square h square upon 8 ml square plus ny square h square upon 8 ml square, where nx and ny are both are equal to nx is equal to 1 2 3 4. Similarly ny is also equal to 1 2 3 4, but there can be cases when nx is not equal to y, right? Let's say for certain energy state, nx value for nx is 1, and whereas for ny it is 2. So we have, what happens, the two values are different, that's why we are writing as nx square and y square. So if we take h square upon 8ml square common, what do we get? Nx square plus ny square into h square upon 8ml square. So this is the function. This is equal to energy in 2D box. This is the energy in 2D box. 2D square box. 2D square box. So the energy of the particle in the 2D square box is equal to nx square plus ny square into h square upon 8ml square. This is very important to remember, because the questions usually come from this part, where you have to find the degeneracy of the energy state. What is the degeneracy of the state, that we will discuss in the next video, not in this video. Now let us see what will be the value of psi for 3D cubic box. (3D cubic box). What does this mean? Length is equal to breadth is equal to height and is equal to L. Length is equal to breadth is equal to height and is equal to L. Now for a 3D cubic system, psi, we will write psi x, y, z. Why? We are now taking all the three coordinates psi, x, y and z. This means we are talking about psi in a 3-dimensional space is equal to psi x into psi y into psi z is equal to, what will we get? Root 2 upon L sine n pi x upon L into root 2 by L sine n pi y upon L into under root 2 by L sine n pi z upon L. This implies psi x, y, comma z will be equal to under root 8 upon L cube sine n pi x upon L into sine n pi y upon L into sine n pi n pi z upon L. So this is the wave function in 3-dimensional space. So this is the wave function for a particle in a 3D box, 3D cubic box. 3D cubic box. And now let us see the energy. Energy will be equal to energy along x component plus energy along y component plus energy along z component. Now energy along x component is nx square h square upon 8 ml square plus along y it will be ny square h square upon 8 ml square plus along z it will be nz square h square upon 8 ml square, or what we can write it as is equal to nx square plus ny square plus nz square into h square upon 8 ml square. So this is the expression for the energy of a particle, total energy of a particle in a 3D box. This is the energy expression for the energy of the particle and the total energy of the particle in a 3-dimensional box, and this is the expression for the wave function in a 3D box. So this is all for today's video. Thank you very much. I hope you like my video. If you like my video, please do hit the like button and subscribe my channel. Thank you.